Hi everyone, my name is Lauren Tom, and today I will be talking to you about why the computer labs at UVM are not virtualized and the options I would present to the CIO of UVM to consider increasing the number of virtualized desktops here. The agenda for my presentation is to give a brief description on what desktop virtualization is, to talk about the VDI pilot project in Calkin that was a Clean Energy Fund project, the current status of UVM and the number of virtualized desktops that are on campus today, along with the benefits of using thin clients and the savings that come with it. Also, a SMART goal I would present to the CIO of UVM. So, what is desktop virtualization? Well, desktop virtualization operates as a client-server computing environment that executes applications on a remote operating system that is linked to the local client device over a network that the user is interacting with. Desktop virtualization can significantly reduce the amount of energy that is being used by the computer labs on campus, and I will go into more detail about that further on in the presentation. But first, let's take a look at where UVM is at in terms of virtualizing computer lab desktops. The Virtualized Desktop Project was a pilot project that began in May 2012 between the Enterprise Technology Services, ETS, and the School of Business Administration. It focused on virtualizing the smaller computer lab in Calkin to create a demonstration of how VDI can be configured in order to encourage the rest of campus to follow suit. The main goal was to reduce energy consumption by computer labs, extend the useful life of the client lab equipment, and to enhance lab management flexibility. The project first ran a test run with the computers located on the second floor of Calkin. These were the first virtual desktops deployed on campus. Crazy, right? Well, one used a thin client, while the other was a repurposed Dell with a 60 GB SSD that replaced the traditional hardware to decrease power consumption and heat while also increasing its performance. By January 2013, the VDI lab in Calkin was fully running with 7 new thin clients and 7 repurposed desktops, and in the spring, they had an open house of the lab that showed campus lab managers the energy that can be saved through desktop virtualization. However, the lab in Calkin is no longer virtualized due to technical issues and the fact that desktop virtualization works better with 50 work computers versus the 14 that were in the lab. But this was the first virtualized computer lab on campus, and in spite of its demise, it introduced the benefits of implementing VDI software and has brought UVM to where it is today on virtualizing its computer labs. Today, UVM currently has around 825 semi-public workstations on campus and computer labs, and about 230 of them are virtualized. There are 8 computer labs using desktop virtualization, along with some computers located in the library and some faculty lecture stations. UVM seems to be off to a good start, and Mike Austin, the System Administration Director, says that they will be working on 2 to 3 more labs this year, and they anticipate that other departments will reach out as the summer approaches. But how can we encourage UVM to increase the number of virtualized desktops on campus? Well, one way is to lay out the benefits of using a thin client and the potential savings that could be seen by virtualizing desktops on campus. Using data from the VDI pilot project, let's assume that the UVM computer labs run about 8 hours a day and 243 days a year. If UVM were to virtualize 500 of its computers, the annual savings in power could be 57,633 kilowatts per hour. The potential cost savings are estimated to be $9,651.96 per year. Now, imagine if all the 885 computer workstations on campus were virtualized. Using the numbers from the previous example, those savings could be an estimate of $14,193.63 per year. If the CIO of UVM is worried about how much it would cost, it seems that the savings that virtualizing these labs will have will pay for itself within a few years. Repurposing old machines will also save costs on repurchasing hardware. This also goes into the benefits of thin clients, which I will go into next. There are many benefits to using a thin client. To start, UVM computers typically need to be replaced every 3 to 4 years. The lifespan of a thin client is typically 7 to 10 years, which extends the useful life of the equipment, along with reducing the need to replenish hardware as frequently. We are also extending the useful life of existing hardware that might otherwise be disposed of or put into storage, since we are increasing the efficiency of the existing hardware. This will drastically reduce the e-waste and storage needs on campus. By virtualizing these labs, there will also be lower administration and hardware costs, since the virtualized desktop will be managed at the server, which creates less of an opportunity for hardware failure. Even if the thin client breaks, There is no longer a need to call and wait for a specialized hardware engineer when you can simply replace it yourself. Thin clients also increase security because the chance of physical theft is reduced since there is no data that is actually stored on the thin client. Besides giving the CIO of UVM this long list of facts and potential savings desktop virtualization can bring, outlining a SMART goal to present her will help determine the feasibility of the project and what it could look like in the future. It is important to use a SMART goal setting framework since it helps outline and achieve the goals of increasing the number of virtualized desktops on campus that the CIO of UVM can really visualize. The goal I would propose is that UVM will virtualize 500 computer lab workstations by 2017 by using thin clients or repurposing desktops to reduce power consumption and electricity costs. This goal specifically states how many desktops UVM will virtualize, the process that is going to be used to do so, and the time frame of implementing VDI. It is measurable since reports can be retrieved on how much was spent on PCs and how much UVM is saving by looking at power and cost savings. A metric can also be made to see how much each virtualized desktop is saving the university in comparison to a regular desktop and the amount of power that is being used. This will give the CIO a goal that will help UVM continue to move forward with desktop virtualization. To conclude my presentation, desktop virtualization can significantly reduce the amount of power that is being consumed by computer labs on campus, while also improving the efficiency of the hardware being used. Since virtual desktops run on servers in the data center, it makes these servers more reliable and powerful. UVM is making good progress from the first virtualized lab in Calkin, and with the anticipation of Mike Austin working on 2 to 3 more labs this year, it seems UVM is making strides towards increasing the number of virtualized desktops, and hopefully, with this increased amount, it will encourage other departments to follow suit. Well, that is all I have for desktop virtualization at UVM, and I thank you all for your time.